All right, so we're going to start off by finishing where we left off before the assembly. So if we are still in objective 1, and I'm just trying to determine if something is a function, let us look at this example here. Y equals the absolute value of x. And then I also want to look at this example here. X equals the absolute value of y. So remember, x can repeat, but y cannot. So if we just choose a random number, so let's choose like we did the other day, x equals 2. So if I plug in 2 there, the absolute value of 2 we find out is just 2. So we got one single number out of our answer. So therefore, this one right here is a function. But when we come over here and we let x be 2, we see that the absolute value of y equal to 2 can either be y equals 2 or y equals negative 2, because both of these results give us the positive 2 that we get. So therefore, since we got more than one a y value as an answer, this one would not be a function. All right, so let's go into objective 2. Which is applying the function notation. All right, so if you're given, given f of x equal to x squared plus 3x, g of x equal to 1 over x, h of x equal to 5, and k of x equal to the square root of x plus 1. And I asked you to find these answers. I would want you to find k of negative 2, k of negative 1, k of 0, k of 1, and k of 3. All right. So to do that, you would literally pick out of all these equations, you would go to the one that has a k, and then you would plug in negative 2 in for the x of the equation k. So I choose this one right here because that's the one with the k, and I'm just going to plug all this in. So we see the square root of negative 2 plus 1 gives us the square root of negative 1, which we know is I. Or in some situations, it'll also be a no solution if they're asking for real answers, which you could just say the empty set, or you could even say undefined. On the test, I would accept any of these answers. On your homework, I don't know which one it's going to really ask you. Then we can do the negative 1. So this will just be negative 1 plus 1, which we see is the square root of 0, which is 0. That would be your answer. Then you could have the square root of 0 plus 1, which is just the square root of 1, which would give you 1. Then you could have 1 plus 1, which is the square root of 2, and you would just leave it like that. Then you could have 3 plus 1, which is the square root of 4, which gives you 2. All right, so that's all you would do is literally figure out which equation you have, plug it in, and then just evaluate. All right, so I want to do another equation, but I'm going to need this stuff here. So I'm going to put it right here. If I would ask you to find f of a, So I'm no longer looking for a number, I'm looking for an equation. The way you would do that is you would take A and you would just plug it in to this equation. Because it has an F, I'm going to the F equation. I'm going to replace every X with an A. So by doing that, instead of X squared, it just becomes A squared. And instead of 3X, it just becomes plus 3A. And that's literally all you would have to do. If you see a situation like that, that is what you do. All right, let's look at another example then. If I asked you to find f of x plus h, then we would just plug it into the, well, let me pause there. I want you to find out what f of x plus h is given f of x is equal to negative 2x squared plus 6x minus 3. So in this type of situation, you would take x plus h and you would replace every x value in the equation. So to find out what f of x plus h is, instead of negative 2x squared, this now becomes negative 2 parentheses x plus h, because I'm replacing x plus h. I'm replacing x with x plus h squared, plus 6 times x plus h minus 3. All right, now here's the mistake a lot of people make. This is not x squared plus h squared. This is two binomials. So this should be negative 2 times x plus h times x plus h plus 6 times x plus h minus 3. So I'm going to fold this out. So that gives me x times x, which is x squared, x times h, which is xh or hx, however you want to write it. I guess technically alphabetical order would be the more proper way to write this. So that's hx plus hx and then plus h squared plus 6 times x plus h minus 3. You can then combine like terms. So this is negative 2 x squared plus 2 hx, because there's two of them, plus h squared plus 6 times x plus h minus 3. And then we're going to distribute. That gives me negative 2x squared minus 4hx minus 2h squared. Distribute this one. So that gives me plus 6xh plus 6h. Oh, my bad. 6x plus 6h. And then just the minus 3. Then we'll just combine like terms. There's no specific order here. So I'm just going to look at this first one. I don't see anything to combine with the x squared. I don't see anything else that has an h and an x in it. So that's going to be just minus 4hx. I don't see anything else with a h squared. So that's going to be minus 2h. Well, actually, let me just pause here. Because as I'm trying to combine like terms, I'm starting to realize there is no like terms. So this would be our answer. And again, you would combine like terms if you could. In this case, there's nothing to combine with. All right, so let's look at the next objective. So in objective 3, I want you to determine the x and y intercepts of a function defined by y equals f of x. So remember back in Algebra 1, we learned f of x is just a fancy way of saying y. So if I give you, so in this example, I want you to find the x and y intercept. Let's take k of x equal to negative absolute value of x plus 2. Okay. So just like in the previous section of 2.1, define x-intercepts. We know y to equal 0. Well, k of x is just a fancy way of saying y, so we're going to replace this with 0 equals negative absolute value of x plus 2. Now we're back to unit 1, in which we're just going to solve. So we will subtract 2 on both sides. Divide by -1 to get rid of that negative. So I get 2 equals the absolute value of x. And then recall that two numbers can do that. So x equals 2 and x equals -2. Again, I'm good here. Your homework may want you to write it as coordinates as such. To find the y-intercept, again, we know that x is equal to 0. So I'm just going to replace x with a 0. That's going to be negative absolute value of 0 plus 2. So that's just absolute value of 0 is just 0. Apply to negative is just 0. And then 0 plus 2 is just 2. I'm good with this answer. Again, your homework may want you to write it as a coordinate. All right, that's pretty much it, which is just like in 2.1. So our last objective, I believe is the last objective. Maybe not. In objective 4, we're going to determine domain and range of a function. All right, so if we look at this first example, and I'm going to do my best drawing since I don't have a grid paper here. Let's say there's a point right here at -4, -2. There's a point right here at -2, 0. Let's say there's one at 0, 2. Let's say there's one at 2, 4. And let's say there's one at 4, 6. If you were asked to write the domain of this guy, just like earlier in the other day's lecture, I'm just going to write all the x values from least to greatest. So I'll just be -4, -2, 0, 2, and 4. And then do the range, same concept. I'm going to do all the y values in least to greatest. So again, that would be -2, 0, 2, 4, and 6. Right? And that's pretty much all you would have to do in that situation. So let's look at another example. Again, I'll do my best drawing. That's not a good one. All right, so what you need to recall for domain, that deals with the x value, and the best approach when coming to a graph is you want to go from left to right. So this is what we call continuous data because it's just straight lines. The stuff we have been seeing is what we call discrete data, which is just scatter plots, basically. All right, so to do this, I go to the farthest left number, but this arrow indicates it infinitely keeps on going, so therefore the farthest left number would just be negative infinity. It would get a parentheses because infinity signs always get parentheses, And then we go to the farthest right number, which is my best drawing I could do. Looks like it's at 4. But we see that it has an open circle. An open circle indicates a parentheses because it's not part of the set, but every number leading up to 4 would be. So there's your domain. Your range would be your Y value, and we go bottom to top. So again, I see the arrow infinitely going down. So I see that there is no bottom. So that would just be, again, negative infinity, indicating that it's infinitely going down. And then the top, I see that it looks like it's about right here. And that looks to be at 4. But this time, since that's a solid dot there, it will get a bracket because it is included in the set. All right, let's look at another one. All right. So again, looking at the domain here, again, domain is left to right. I see that there's an arrow on both the left and on the right side. So that tells me that this is going to be negative infinity to infinity. Or you can even say all real numbers if you would like for the test. On homework, they might want this. Remember, on range, it is bottom to top. We see that we have 2 arrows going down, so it's definitely going to be negative infinity. But then when we look at the top, and again, my best drawing here, we see that it goes all the way to 2. Seeing that that was a solid dot there, we can see that it will be a bracket. Right, so let's look at some more examples. Make sure we're comfortable with finding domain and range of different things. So if I was to give you things like this, so let's look at these type of equations. So k of x is equal to x plus 6 over x minus 2. We'll look at j of x equal to x plus 6 over x squared plus 2. And we'll look at p of x, which is equal to x plus 6 over x squared minus 2. Alrighty, so when you are giving a rational function, because a fraction means rational, recall that the only thing that can't happen in a rational function is that the denominator cannot be 0. So if I'm looking for the domain, I know it's going to be every single x value except what makes the denominator equal to 0. So all we're going to do here is we're going to take x minus 2, we're going to set it equal to 0, and we're going to figure out what x can't be. So we'll add 2 to both sides, and we see x cannot be 2. So to write the domain out in interval notation, you would write negative infinity to 2, parentheses, union 2 to infinity, indicating it's every single number except 2. Okay. When we move on to this next one, we'll do the same thing. So x squared plus 2 equals 0. We subtract 2. X squared equals negative 2. But then when we take the square root, since there is no real number of the square root of negative 2, this would indicate that there are no limitations and x can actually be every single number. So this would then be just negative infinity to infinity because x can be all real numbers. Then we move on to part C. We see it's x squared minus 2 equals 0. So again, we would solve for x. So that's plus 2. So x squared equals 2, and take the square root of that result. But don't forget, when we do take the square root of it, we don't forget the plus or minus. So basically, x cannot be the positive or negative version of the square root of 2. So the way we would write that is we would go negative infinity to the negative square root of 2, union, negative square root of 2, all the way up to the positive square root of 2, union, square root of 2, all the way to infinity. And that would be this guy's domain. All right, let's look at some others. Let's look at y of t equal to the square root of 16 minus t. We will look at w of t equal to the square root of t minus 16. And we would look at d of t equal to 1 over the square root of 16 minus t. Okay, so what you need to remember is with radicals, this is what a square root is a radical, is that you have to be a zero or positive number. It cannot be a negative. So we're just going to take the inside of the radical, 16 minus t, and set it to greater than or equal to 0 to figure out what t must be. So we subtract 16, so we get negative t is greater than negative 16. Then we're going to divide by -1, but recall from the previous unit, anytime we multiply or divide by a negative number, we must flip the inequality sign. So then t must be less than or equal to 16, but we do want to write that in interval notation. But if you cannot visually see that, draw your number line, put 16 in the middle. This will be a solid circle since there's a line underneath it, and I'm shading in this direction. So I can see my interval notation's farthest left number would be negative infinity all the way to 16, and then there would be a bracket on 16 because it is included. Do the same thing with part B. So I get t minus 16 has to be greater than or equal to 0. I'll add 16 over, so t must be greater than or equal to 16. Again, if you visually cannot see that, just make a number line, put 16, solid dot, and we can see it's going this way. Remember the inequality points in the direction it's supposed to be shaded. So I see my farthest left number is 16. It would have a bracket because it would be included all the way to infinity because it keeps on going to the right. This one's a double whammy. Here, I have the square root, which has to be greater than or equal to 0, but then it's also part of a rational equation because it's on the bottom of a fraction, and it can't equal 0. So in this case, when you're ever limited to this case, then you would take the 16 minus t and just set it to greater than 0. It can no longer equal 0 because that cannot happen in a fraction, but it still also has to be a positive number. So I would subtract 16, so I get negative t must be greater than negative 16. Divide by -1, so I see t must be less than 16. All right. So again, you have to flip the inequality. If you don't visually see it, draw your 16. Open circle this time because there's no line underneath the inequality. And then you would just shade to the left. So we can see that the farthest left number is negative infinity. Farthest right number is 16, but this time it would be a parentheses since you cannot actually equal 16. All right, so let's look at some more interesting situations. Let's look at f of a equal to 8 minus the absolute value of a minus 2. Let's look at g of a, which is equal to 5 over 8 minus the absolute value of a minus 2. And then the last one would be h of a equal to 5 over 8 plus the absolute value of a minus 2. When you have a situation like this is an absolute value function. If you recall, an absolute value function is the one that makes the v. Notice there are no gaps in it. So therefore, there are no limitations to the domain. So all absolute value functions that are in this setup would just be all real numbers. So we'll write it as negative infinity to infinity. Here, the only limitation we have is that we can't have 0 on the bottom. So I would just take the denominator, set it equal to 0 to figure out what a cannot be. So I subtract a. I get negative absolute value of a minus 2 equals -8. divide by -1. So I now get the absolute value of a minus 2 equals 8. And then again, two things can do that. So a minus 2 can either equal 8 or a minus 2 can equal -8. If it's this, I just add 2. So a could equal 10 or a could equal positive 2 would give me -6. So this is what a cannot be. So when I write the domain, it would just be, again, -infinity to the smallest number, which in this case is -6, union -6 to the next number, which is 10, union 10 to infinity. And there would be your domain. Same concept with this other one here. We get 8 plus the absolute value of a minus 2 equals 0. So I subtract 8. So I get absolute value of a minus 2 equals -8. Think about this question, though. Recall, absolute values are always positive. So the absolute value here will always equal a positive number. So there is no number that an a can be that would equal a negative number. So therefore, there are no limitations here, and this would be -infinity to infinity. Okay? So since the absolute value is equal to a negative number, there is no value that would make that happen. So therefore, it's every single number will work. All right, so there's one more objective, and then this will wrap this up. So this is objective 5. And it's interpreting. So I want you to interpret a function graphically. So if I give you this graph here, again, best drawing that I can make. All right, so this is a graph that's given to you. There is a lot of questions here. The first question is, I want you to find f of -2. If given this, you just go to -2 on the graph, and this is going to be real hard, but it technically actually goes right there. So I would go to f of -2, and I would see that it's equal to 1. So again, if you're asked this question, you just go to the x value, figure out where it hits on the graph, and then see what the y value is. The next question, similar, find f of 3. So again, I go to 3. To make this a little bit easier, we'll see that it actually hits about right here. You'll have a better graph when you go through this process, but you'll see at f of 3, the y value there is also 3. This next question is asking, find all x for which f of x equals -1. What this means is I will go to -1 on the y value, and I will figure out what are all the x values that when y equals -1. And if you notice this blue line I just drew, it did not go through any of the graphs. So therefore, there are no x values. All righty. Then I move on to part D. Part D says, same concept. You want to find all x for which f of x is equal to -4. So this time, let me do a different color so we can see. I'll go down to, see, it's 1, 2, 3. I'll go down right here. And I'll choose all the X values in which this happens. And I can see that this happens. Let me kind of clear this up a little bit. Oh, go back. Just to clarify, this is an open circle right here. All right, so that means all of these X values from here to here are part of my answers. So this will be from 0 all the way to 2. 0 is included because it was a solid dot, but 2 would be in parentheses because it's an open dot. So these are all the X values in which this happens. There's another type of question. I'll ask for all of the X-intercepts. So I can literally look at the graph and I see there's an X-intercept right there. So that would be just -1, 0. Done. The next kind of question I can say is, hey, what's the Y-intercept? Again, I can come and I can see that's an open circle, so that doesn't count. But this one right here would count because it's a closed circle. So I see that that would be 0, -4. The next one asks for the domain. So I go my farthest left number. I see an arrow to the left. So I see that's -infinity. I do want to see if there's any breaks. I see a break here, but this closed circle is filled in with this one. So that doesn't, so I have no break in the X's. I come here, I have an open circle, but then I have a closed circle again. So again, I have no broken spots there for the X value. So this would be -infinity to infinity. So basically what that means is every X value I choose, I will get a Y value of something. And then of course, the last type of question they'll ask is what is the range? And remember, range is bottom to top. So I see at the bottom here is at -4. And then it stops. There's no continuation there. So that would be a curly bracket, union. I then see another one at 0. And it would be a bracket because it is a solid dot or a solid line. I do see a break here, but then this solid dot over here covers that up. And so therefore, every other Y value is chosen, meaning that whatever X values I choose, I will get some type of Y value. And so there is your range. And that'll pretty much wrap up section 2.3. So let's jump right into section 2.4. Which in this case will be linear equations in 2 variables and linear functions. So hopefully this one feels more like algebra 1. All right, the first objective, objective 1, is to graph linear equations in 2 variables. First example we'll look at is -2x plus y equals 4. This is called standard form. So we want to put this in slope intercept form, which is y equals mx plus b. So I'm just going to add 2x over. I cannot combine these. So this is just y equals 2x plus 4. Once you have it in this form, you can then go to graph. This is called the y-intercept. So I will start at 4 on the y-axis. This is called your slope, which is rise over run. So that's technically 2 over 1. So I'm going to rise 2 and then run to the right. So if you're going to go up or down, and then always to the right. All right. Once you have two dots make a line. So I'll connect the 2 dots as best as I can. And then I'll draw my graph with arrows. All right. So there's that. Let's do another example. Let's look at y equals 4. If you just have something like in this form, y equals b, just a random number, it will make what we call a horizontal line. So I'll go to the 4. Now we'll just draw a horizontal line that has a slope of 0 since it does not have an mx. All right, let's look at another one. 3x minus 2 equals 4. Again, I need to solve for, looks like just x in this situation. So I'm going to add 2. I get 3x equals 6, divide by 3, and I get x equals 2. So anytime you got this x equals a type of situation, this is just the example, it makes a vertical line. So you'll go to x equals 2, and you will make a vertical line. This actually has what we call a undefined slope. That's my best interpretation of it. All right, let's look at another example. Or not. Let's go to the next objective. Objective 2 is to determine the slope of a line. Let me back up a little bit. Didn't realize there's another part to these questions. It also wants you to find the x and y intercept. So again, x-intercept, we let y equals 0. So if I go back and I substitute this in, this is negative 2x plus 0 equals 4. So that's negative 2x equals 4. So that's x equals negative 2, which again will be negative 2 comma 0. Y-intercept, you could do the same thing, plug x equals 0, but you've already solved it when you put it in mx plus b format. So you can see that it's just going to be 0 comma 4. Do it the same way. Here, when you have a y equals number, there's only a y-intercept, and that would be 0 comma 4. There is no x-intercept. And in these form, there is no y-intercept, but the x-intercept would be just this single number here, which would be 2 comma 0. All right, so I don't want to forget that part. All right, so now going back to this one, determine the slope of a line. Let's look at this guy. If I give you the points negative 100, comma, negative 16, and 84, comma, 30, to find the slope of a line, it is y2 minus y1 over x2 minus x1. Best approach, label it. x1, y1, x2, y2. All right, so when we plug this in, it will be 30 minus negative 16 over 84 minus negative 100. Recall that 2 negatives make a positive. So this is really 30 plus 16, which is 46. And this is 84 plus 100, which is 184. And then if you reduce this, let's see, I know that goes into twice at least, so that'd be 23 over 92. Why do I feel like 23 can go into this? 23, 46, 46 times 2 is 92. So 23 actually goes into 92 4 times. So you actually get a slope of 1/4 there. All right, and then that's it. That's all you do. So let's do another example. If I give you fractions, -3, 2/5 and 4, 3/10. Same formula. Label your stuff x1, y1, x2, y2. So I would get 3/10 minus 2/5 over 4 minus -3. Again, two negatives make a positive. To do fractions, remember they have the same denominator. So if I multiply both of these by 2, I get 4/10. So now this is really 3/10 minus 4/10, which is -1/10. 4 plus 3 is 7. When you have a fraction over a fraction, this is where you keep, change, flip. So I'll keep the first fraction as -1/10, change the multiplication. Technically, a whole number is over 1. So I will flip that, and I will have 1 over 7. You're welcome. Then just multiply straight across. So -1 times 1 is -1. 10 times 7 is 70. So your slope here would be just -1 over 70. Remember to not be afraid of fractions. All right, so that's how you can do it for that type of slope. A different interpretation, I could give you a graph and ask you to find the slope. So here's another example. Again, doing my best job for your graphs here, guys. Let's say I have a line like this. We talked about this a couple examples ago, but anytime you have what we call a vertical line, the slope is undefined. Because again, this is a vertical line. All right. All right, let's look at this type. If I say, what is the slope of a line parallel to the x-axis? Okay. One thing you need to know is parallel means same slope. So if I'm parallel to the x-axis, so here's a graph. This is the x-axis. So if I'm parallel with this guy, this is what we call a horizontal line. That's what an x-axis is a horizontal line. And if you're parallel with it, it's going to have the same slope as this horizontal line. And horizontal lines have a slope of 0. So if it's parallel to the x-axis, it has a slope of 0. All righty, let's keep trucking along. So objective 3, we're going to apply the slope intercept form of a line. Recall slope intercept is y equals mx plus b. It's called slope intercept because you're given the slope and you're given the y-intercept. Just an FYI. All right, so let's look at the example here. We have 0.03x plus 0.04y equals 0.12. If you don't like decimals, completely fine with me. Notice this is the tenths and then this is the hundredths. If you want to get rid of the decimals, you must multiply by the farthest reaching decimal, which in this case is the hundredths place. When you do that, this will literally just become 3x plus 4y equals 12. You no longer have decimals, and so we just want to basically write the equation in slope-intercept form. So we're going to solve for y. So let's keep on trucking with that. So minus 3x. So I get 4y equals, again, you can't combine that. So that's negative 3x plus 12. And then we're going to divide everything by 4. That goes away. I can't reduce that one anymore. So that's negative 3/4 x. And then 12 divided by 4 is just 3. And let's see. So write the equation in slope-intercept form. This says determine the slope and the intercept. So the slope is going to be the number next to the x. That's negative 3/4. Do not write the x. That would be wrong. It's just the number next to the x. And then the y-intercept is going to be 0, 3, because it's just this number here. Let's see what else. And then graph it. All right, so we'll take this and we'll graph it. So again, this is our starting spot. So I'll graph at 3. And then this is my slope. So if it's negative, I'm going to go down 1, 2, 3, and then always to the right. So there's my second point. It just takes 2 points to make a line. So there you go. All right. Let's see. Let's do a different type of example. I'll have to make another video because I have to go sub for a class.